Hello, welcome back. Uh, yeah, I didn't check yet your homework because I'm recorded in the past, but for now you already should send me all your homework for the last test about classes and vectors. And today we're gonna these two classes we're gonna go through the forces. I will give you a link for this book, Nature of Code. It's quite interesting book about processing, mostly P5.js. P5.js we're gonna learn a little bit more at the end of this semester. So, but I very recommend you to check this one, and I also give you a link on the Cadenza Processing Foundation. You have the online course, The Nature of Code, that cover pretty much all this book. So you will have introduction to processing P5.js, again vectors and forces, what we did and doing now. Steering behavior, it's part of the forces. Fractals, more like how to generate invisible patterns and what is fractals it is, and genetic algorithms. This part very nice and interesting. Genetic algorithms, we're not really gonna cover it during our course because we do not have enough time, but I strongly recommend you to check this out, and in the book also. It's gonna be autonomous agents, evolution of code, I think, and now they have new part, neural networks. So this is very interesting to will tell you how you can make your works more independent from you and from people, right? How you can create some work that can behave by himself, to make decision and to apply this decision. So this part I will highly recommend you to check later. But let's back to the forces. So first of all, what is force? As we can see here, and as general introduction from physics, a force is a vector that causes an object with mass to accelerate. We can go to Wikipedia and we will get pretty much the same result. And yeah, this book it's not the one recommended for class in the general, but I highly recommend you to check this book and these courses. So in physics, a force is any interaction when on a post will change the motion of an object. So it's more like scientific definition, but pretty much the same. A force can cause an object with mass to change its velocity. Change velocity, what? Acceleration change velocity, right? Which include to begin moving from the state of rest to accelerate. So it is what the force is. So if we have any object, now let's say I have table and I have ball on it. Let's do better looking ball first. I have ball and I have table. So now at the beginning this ball in the static position. is happening here. Okay. Photoshop. Okay, so I have table and I have ball on it. If I will push this ball this direction, for example, I need to apply, if I want to move this ball in this direction, I want to apply some force to this object. So I need to push it, right? And when I push it, the ball will start to move in the direction where I push it, right? So here you can see force is the vector, pretty much, right? So I push in this direction, I have vector, where the direction, the normal of the vector, it gives us direction, where force, and magnitude, the length of the vector, it's the power, how strong this force. So this have normal and this is have length, but length in our case it's power now. So then bigger length, then stronger I push the ball, then more far away the ball gonna move, yeah, and more faster. Then less power, then slower ball gonna move. Direction, it just give me direction. So if I create another layer, if I apply force this way, the ball gonna move this way, right? With the same acceleration that gonna be based on the force. But we have one more thing here. Don't forget, so a force is a vector that causes an object with a mass to accelerate. Why we have mass here? So if you, for sure you study physics in the school, we have the Newton first law. Right, Newton first law state object at rest stays at rest and object in motion stays in motion. So an object at rest stays at rest and the object in motion stays in motion at a constant speed and direction unless acted upon an unpredicted force. So if I do not apply the force, my object will stay at the same position, right? When applying force, my object will start to move. And why do we have the mass here? Because again, if we will remember physics, like physics, the second law of physics, force. Okay, I want to change color. So force is the mass multiplied by acceleration. So this is vector, this is acceleration. This is F, is this force, right? And the mass is the size of the object. Let me move up. So this is object have mass. So with simple mass we calculate. Okay. Acceleration, the speed, how speed gonna change of the object, will move with the force divided by mass, right? What does this mean? Okay, if we have like small object, and we have, for example, the big object. So this is big object, it's a yellow. It have much bigger mass, right? So if I will apply the same force to this object, to bigger object, as the force I applied to my small object, so I apply the same force f1, let's say f2, and here I can tell f1 equals okay, someone Photoshop thinking too long, maybe meta f1 equals f2. The acceleration of this object gonna be much smaller. Okay, if I have glass of water or I have car, if I will apply the same force to the car and to the glass of water, okay, glass of water, it's easy to move, right? I don't need to apply much force. I just with my head I just can move it very easily without any tension. And if I apply the same force to the car, it's not gonna move at all because it's too heavy. I does not have enough power and enough force to move it. So that's why here we have a mass, right? So to make object move, we need to give some acceleration to the object, but this acceleration will be based on the force we apply to this object and on the mass that object have, right? So let's try to create some simple sketch. I create new sketch, and first of all I go to save it, and I will create one new object. I will call object. So let's create class obj, and we have our processing sketch. Let's say the same void setup, void draw, setup size 600 pixels. In the draw, let's say background white. Okay, let's save, run. It works fine, right? So now we can sync. So first, what we need to know when we're talking about force here. Okay, at the beginning, for first few examples, we're not gonna talk about mass. Let's assume that all our objects have the same mass and it equals 1. If mass equals 1, the final equation gonna be acceleration equals force, right? So that's what we're gonna implement for now. Acceleration equals force. So first of all, our object should have something what? Parameters. What parameter we have? The first one is gonna be p vector position. Second, we need p vector acceleration. Next one we need p vector velocity, right? And this is pretty much all. And we need to create constructor. So we create default constructor. When we create the new object, position gonna be, again, let's use this syntax to make it clear. This position equals new p vector 0 0, right? So when we create the new object, this acceleration equals new p vector 0 0. So when we create new object without defined arguments, it's create just empty object. Velocity equals new p vector 0 0. And now here I can create, for example, I can say n equals 2 by g objects equals by g objects, right? And done. By g n. Test run, no problem, nothing happens. We initialize it for int y from 0 I less than n, I plus plus. We go for the all objects. Objects I equals new object. So empty. And let's for make it easier for constructors, and let's do one of methods. What kind of methods we need to do? Okay, first of all, let's draw our object, right? It's gonna be void because it's not gonna return anything. Void draw. What it's gonna to do? Push matrix, pop matrix. You see here how it's clear and easy now to use push matrix and pop matrix inside of each object, right? Also, so I don't need to carry. If I will draw some object, it will affect other object or other element on the screens. So now it's much more clear and interesting. And let's do fill black ellipse, this position x, this position y, let's say 2020, right? Let's do it here again. Now for int I 0, I less than n, I plus plus, we go from the all and we write objects y, draw, test it. Okay, I have object here. Let's create one more constructor. Objects p vector position, and I will copy this one, except here I will just transfer position here. Again, you see I have this pose and this pose and here a pose, and it's not the same yet because this pose p vector I will get from the constructor. If I will call here new p vector, yeah, I just do new vector, random width, random height, so now you see now our objects with some random position, right? Always okay. What's here happened maybe a little bit, but pretty much I just create a new vector object inside my object plus, yeah. So okay, of course I can write something like this: vector temp equals this, and after put here temp. It will be the same, but I don't need really to use temp now or whatever, because I don't want to save this random position. Yeah, I need just them when I initialize the object. So I do like this now. And what also we need for our methods? Okay, let's put our draw in the bottom. Another vector we need void update. So update vector, it will update position of our object. If we go here, I create new object and I can see I have my object here now. I use something. Okay, I have my object here. This is position now, x, y, the vector, and what is position? Position is gonna be position. It's the position of the object, yeah. But how it change? It change over time based on the speed of the object. So position next frame will be position of previous frame plus velocity. Velocity is speed. Okay, let's do not do this way. So velocity equals speed, right? So to my previous vector position, I need to add vector velocity to change my object. So velocity speed is how much my object move during this frame. So here it's gonna be like this. You already know vectors. So again, let's do it clear. This position add this velocity. We start, they does not move because they doesn't have velocity now, right? Okay, I can set up velocity like this, for example, when they start. So now they will move, they should, I need to call this function, update. So before to draw object, what I'm gonna to do, I need to call this function first, right? So now objects y update this position at this velocity, and this velocity should be 1 0 0. Let's check it out. Print this velocity. Oh, it's 0 0 0. Because now I use this vector, right? Yes, so velocity I should define here. One zero zero. Now I delete the wrong one. I need to delete print. Yeah, so now you see my object move. Yeah, because the speed of my vectors 1 pixel per frame. So now they're gonna move. Okay, I don't want it to do now. We figure out, but how we calculate velocity? If you go again to physics, what we have velocity. It's gonna be previous velocity plus acceleration, right? Acceleration, this is how we speed up it. Okay, it's in the car. Yeah, you can easily get, if you, when you press acceleration pedal, your car going faster. When you press brake, your car gonna be stop. So it's have acceleration in opposite direction. So here, before we add velocity, I need to do like this velocity at this acceleration. Right? And again, what we need to think, each frame we need to this acceleration set to 0, 0. Why do we do this? Why each frame we need to change acceleration? Because acceleration is the sum of all forces, sum of all acceleration at this current moment. I don't care what acceleration was at previous frame. I don't care what acceleration was previous hour. I just care what acceleration now. So each frame, before I start to calculate the where I need to move it, I need to set up acceleration to 0 first, and after I'm gonna calculate acceleration. So this is what we're gonna do here. So again, I can write here velocity on the speed equals previous velocity plus acceleration, the same with position equals previous position plus velocity. Right, let's save it. So if you go to example, okay, I have small object here. And this object have now, let's say, position, let's talk just about one direction for now. Something wrong here. 0 after, okay, and I need to make it a little bit bigger. Right, okay, this object have now, let's say like now, time 0, position 0, velocity 0, acceleration 0. And so let's say this is my car, right? So now what I'm gonna do, I'm gonna apply some force to my car. So I'm gonna apply some simple force to my car here. So what we have now I have my car here. So this is gonna be time 1. What is gonna be position? So let's say that mass of my car 1, so we don't care about mass now, right? And the first force I'm gonna apply to it, Let's say it's 5. Yeah, this is force 5. So when we apply force 5 to the object mass 1, acceleration gonna be 5 for now. Alright, so acceleration should be 5 here. Velocity. Velocity is our previous velocity plus acceleration. Our previous velocity 0 plus acceleration plus 5, it's gonna be 5, right? And our position is gonna be our previous position plus velocity 5 now, it's equals 5 at frame time 5. Let's say we keep moving on. At next time frame, I will apply, let's say, the same acceleration, the same force. So I will apply the same force. Five. Again, you remember at the beginning of each episode, we set up our acceleration to 0, our time to now. So if we apply force 5, our acceleration gonna be 5 in case we have mass 1, right? Our velocity now is gonna be previous velocity, it was 5, plus new acceleration plus 5. So our new velocity gonna be 10. And our position gonna be our previous position 5 plus 10 current velocity, it's gonna be 15, right? Alright, we go next. Let's say now I wanna stop my car. I press the brake and I will apply opposite force to my car, and this opposite force gonna be, let's say, 3. Okay, minus 3, let's say. Yeah, minus because it's opposite. I wanna stop my car now. What gonna happen now? Here we have our time frame 3, our acceleration we already decided gonna be minus 3 with mass 1, our velocity gonna be 10 plus minus is gonna be minus 3, right? So our velocity now gonna be 7, and here it's gonna be 15 plus 7, and position gonna be 22 at time step 3. So I can apply one more. Let's do one more time. I apply one more acceleration, one more force. So I see my car did not stop as I want, so I press the brake even harder. So now I will apply even bigger force to stop my car. Let's say minus 7. So in this time frame, number 4, our acceleration gonna be minus 7, our velocity gonna be 7, minus 7, 0, our position gonna be 22 plus 0, so we kind of like still at 22 now, right? Time frame 2. So what we see here now, let's draw some simple graph. I change color a little bit. So now I have, okay, this is time. This is gonna be time frame. And with this time frame, I can easily do so. Let's draw first one. Now time, the green one, it's gonna be position. So we start from 0. Let's make it a bit more brighter. And let's put some, okay, let's go back first and put some, so time 0, time 1, time 2, time 3, time 4. Yeah, that's what we have here, and time 5, for example. And now we change it to the color. And let's say see, green one. Green one is gonna be our position. So we start at the 0, and after we start to move, our position start to move to the 5. Let's make it a little bit bigger. To the 5. So we have acceleration 5. Yeah, let's start from acceleration. So we start from 0. After our acceleration gonna be this frame 5. Start 0. This frame 5. Next frame our acceleration also 5. And next frame our acceleration gonna be -3, so it should go here. And next frame acceleration gonna be -7, it should go 7 here. Yeah, so, and let's write here, this is the green one, it's its acceleration. Okay, good. Next one, let's talk about velocity. Let's take the blue one for velocity. We start with our velocity 0 also, and next frame our velocity 5, and next frame our velocity already 10, so just like stride, and next frame our velocity 7, a bit less, and next frame our velocity 0. Right, so let's do this one. It's gonna be velocity. And the last one, position, that's what we care about, so let's do it red. I want this kind of red, orange, hot red. We start with our position from 0. Next frame our position 5. Next frame our position already gonna be 15. So somewhere here. And next frame our position 22, because it's gonna be this position plus this velocity. And next frame our position 22. So here you can see how our position change, right? How our speed change. So we start in the car, I press the accelerator, start, car start to acquire speed, it going faster, faster, till the moment I decide to stop it and I press the brake and it stops. This we see how acceleration forces are applied. And this you see how it's our position change, right? So that's what we're doing here. We set up our acceleration to 0, we add acceleration to calculate velocity, and to change position we add our velocity. Now you can see also why I just cannot directly add my acceleration to the position, because acceleration it's how my velocity gonna change, not how it's not directly affect my position, right? Again, let's save it. So let's finish on this our first class, and yeah, see you soon.